We are now recording. Hi, everyone. Thank you so much for joining us for today's webinar. My name is Beryl Kanali, and with me is my colleague Reshma from Data Umbrella and Marco. I will do a brief intro before I introduce Marco, who's our speaker for today. So as I stated, this video and this webinar is going to be recorded and it will be up on our YouTube channel in the next 24 hours or less. And we will share that on our specific channels so that you can get a chance to view it on YouTube. Data Umbrella is a community for underrepresented persons in data science, and we are a nonprofit organization. As I said, Reshma is here with me, and we also have Christina and Sangam, who are part of the Data Umbrella team, who help us make this and other webinars a success. We have a code of conduct, and we thank you for helping make this a welcoming, friendly community for all. You can support us in various ways. One is by following our code of conduct so that we ensure that we are welcoming and a collaborative space. You can also share our Data Umbrella events with others, which happen once or twice each month. You can also contribute in the open source way, for example, to a new website. You can also contribute to our video timestamps that the link will be shared in chat. You can also contribute by writing a blog, for example, about this webinar, and we can post that on our blog. You can also support us by donating to a nonprofit. You can donate to us through every.org or through Benevity, which is a company match-enabled platform. You can also subscribe to the Data Umbrella YouTube channel, where we'll post this video and other subsequent videos of webinars we've had. You can also view the videos to the webinars we've had before. So several playlists are available on our YouTube channel, like career advice, data visualization, contributing to open source, scikit-learn, PyMC, and NumPy. We also have a monthly newsletter, so you can subscribe to that, which comes out in the first week of each month, and it's on Substack. You can also follow us on different platforms like Meetup, where we post all our upcoming events, YouTube, where you can get our videos, on GitHub, where you can get to contribute to our transcripts, on our job board, where we aim to post jobs that are available in the data science, machine learning, and AI field, and also on LinkedIn. This video has live captioning available, so in case you need to use them, they're on the top right of your screen. The button has been labeled CC. We also have an online suggestion box, so if you have any suggestions on future event topics, feedback on this event, in case you run into any technical issues or any other general feedback, please feel free to use the form. We have an upcoming event on December 10th, which is on Introduction to Git, and that event is posted on our Meetup pages, where you can RSVP to that, and you can also follow us there so that you can get notified when we post our upcoming events. So on today's talk, which is on polars and narwhals, understanding expressions when you're used to pandas, our speaker for today is Marco Gorelli, who is a co-dev of pandas and polars and the author of Narwhals. He's spoken at several Python conferences, taught polars professionally, and written the first complete polars plugin tutorials. He currently works as a senior software engineer at Quantsite Labs, and before getting involved in open source software, he worked in data science and was one of the prize winners of the M6 forecasting competition. He's an advocate for making it more accessible to contribute to open source software and has run several mentored sprints aimed both at the general public and at underrepresented groups in tech. You can follow Marco on LinkedIn, and that's the link to his LinkedIn channel. And with that, I will welcome Marco so that he can get us started on today's talk. Welcome, Marco.
All right. Hello, everybody. Glad to be here. Pretty excited. How are we doing? Let's make some noise. If you make some noise at home, I'll hear you. How do we get the slides back up, though? maybe like this. All right, we've got them back. All right, we're on this. Okay, got some emoji reactions. That's all we need. Awesome. Let's do this. So today we're talking about understanding polars, expressions, and in particular in the context of when you might be used to pandas. We're here at Data Umbrella. And before we talk about expressions, I'd like to talk to you about Dutch expressions, because I recently gave a talk like this at PyData Amsterdam, and there's something I learned about Dutch culture which I'd really like to share with you before we start. And that is an expression called helaas pindakaas. Hi, Pretty in the chat. So helaas pindakaas, I love it. It just means too bad, peanut butter. The peanut butter part does not actually convey any extra information. It's just something you add at the end of the sentence to make it sound a bit cooler, and because it rhymes with the first part. I wish we could spend all day talking about Dutch expressions, but helaas pindakaas, we need to get on with the presentation. So how's today going to work? I'm going to start with a little crash course on why we should care about polars. We'll then talk about expressions, which are really one of the defining differences between polars and pandas. We'll cover multi-input expressions, multi-output expressions, and expressions in group by contexts. We'll then see whether we can re-implement expressions using pandas. Now, we can't really do live coding in this event, but I'm going to share a slide in which I did it beforehand, and hopefully that's just as good. And finally, we can have an even split between engaging Q&A and awkward silence. It's up to you how long each section lasts. Or feel free to ask your questions during the talk. I think it's good if we do this somewhat interactive. Yes, thanks, Beryl. If you have any questions, type them here or in the Q&A tab. Awesome stuff. Let's do this. So, polars has been written about by several companies. G Research, for example, it's a leading quantitative research firm in London. They write about how for them it's not just an improvement, it's a game changer. We see Sky talk about what it does to their processing times. We see Check Technologies, which is a Dutch startup, talk about how it saves them cloud expenses. And we talk about how NVIDIA has considered polars significant enough to develop a GPU engine for it, which is recently released and installable via a new feature flag. Exciting stuff. So from the chat, this webinar is on which topic? It's on understanding polars expressions when you're used to pandas. Welcome. So now that we're all hyped up about polars, let's learn a little bit about how to use it. So first of all, the most fundamental data structure in polars, just like in pandas, is the data frame. But even just by talking about the data frame, there are some differences. So a data frame is just a collection of series, each of which has to have the same length. And the series is a collection of elements which are all of the same type. For example, you could have a string series, an int64 series, Boolean series, float64 series, date series, and all of the data types, they support missing values. This is already a difference compared with pandas. And the string and the column names all need to be strings, and no duplicates are allowed. All right, gonna get myself some tea. Right. Now, if you're coming from pandas, you might try out using a polars data frame by just indexing into it and getting a series out of it. And indeed, yeah, sure, this works. You can get a series out of a data frame. And you might then realize that you can do operations on it. And if you then want to multiply one of the columns in a data frame by 2 and reassign it, you can do that using with columns. However, just because you can, does it mean that you should? As we learned today, there's a better way of doing things, in polars at least. And I hope that once you embrace the polars way of doing it, which is by using expressions, then you might find yourself repeating what every other polars user repeats, which is express yourself. I came for the speed, but I stayed for the syntax. And Oh, right. That's more like it. Sorry, just realized my background wasn't blurred and you can see the dustbin behind me. Hope that isn't too bad. Anyway, let's carry on. Pretend that didn't happen. So, yeah, expressions. Let's talk about expressions, and let's start at the beginning. A very good place to start with a light introduction. Here is the more Polar's idiomatic way of expressing what we just wrote. So instead of indexing into a data frame and using series, we're going to write an expression which defines a recipe of instructions, and it defines how we expect polars to construct our new column. Now, people often get an intuition for what this means, like you're taking some column called price, multiplying it by 2, creating a new column called price doubled. However, this is data umbrella, so we need to go a bit deeper. We're not going to be content with just having an intuitive understanding of what this does. And here is my mental model for expressions. It's basically just a trade offer. So the expression, it receives a data frame, and what you receive back is some series constructed from that data frame. So to put this a bit more formally, we could say that an expression is a function from a data frame to a series. Talking about functions, let's go on a little functional detour. If we consider a function like lambda x times 2, then by itself, it doesn't produce a value. It only produces a value when you pass it an input. For example, if you evaluate it at the value 3, it produces the output 6. If you evaluate it at the value 4, it produces the output 8. And just like that, a Polar's expression does not produce an output until you evaluate it in the context of a data frame. So when you see something like assets.select pl.col price times 2, one way to think about this, if you're coming from pandas, would be lambda df price times 2 evaluated at the data frame assets. Now, all models are wrong. In particular, this mental model is it's just a mental model. Like I would like to think it's useful enough for people to get an understanding of how to use Polar's expressions efficiently. But I just thought, yeah, I need to clarify, this is not exactly what's going on under the hood. All mental models are wrong, but some mental models are useful. And one reason that it's nice to use expressions is because being just functions, they're just like a recipe for creating a series. And that means that Polars can analyze your expressions beforehand, as opposed to having to evaluate everything eagerly. So if you see something like this, and this is an example taken from the scikit-learn documentation, yes, that's right, scikit-learn uses Polars in some of its documentation pages, then Polars can see this and realize that some parts of the expressions are shared, and it can just evaluate this once and share it between all of the results, as opposed to having to repeatedly take the column price and shift it by 1. So there you go. Expressions, even if you're not necessarily worried about working with lazy data frames, even in an eager context, they still allow you to express a lot and have advantages over doing everything using series and eager evaluation. But wait, what about multiple inputs? Because you might be looking at this thinking, yeah, okay, sure, this is cute, this is nice, but when I'm using pandas, when I'm doing my data analysis, I'm often not writing such simple things. I'm often writing functions which operate on data frames, which consider multiple inputs, produce multiple outputs, and so on. For example, suppose that I've got a data frame in wide format, and I want to know, for each date, what's the total price across all assets. Now, it is possible to calculate this in Polars, and let's look at how. Because if we go back to the definition of expression as being a function from a data frame to a series, then nothing prohibits us from considering multiple series in that input data frame. So in particular, we can use an expression called sum horizontal, which will consider the different columns of the input that we specify and produce a single column as the output. This is totally in line with the definition of expression which we saw earlier. An expression is a function from a data frame to a series. Multiple columns can be selected from that input data frame, but the output is always just going to be a single series. But wait. Now, I can feel a bit of tension. I can feel like there's some people here in the session who might have used polars before who are wondering, wait a sec, but I'm pretty sure I've written things like pl.col abc, and then this produced multiple columns in the output. What's up with that? Does this not contradict the definition of expression which you just showed us? All right, let's try to make sense of that, because expressions do still make sense, I promise. So when you see something like pl.col abc, I wouldn't think of this as an expression. Personally, I think of this as shorthand for three expressions. It's three expressions in a trench coat, if you will. When you see pl.col abc times 2, I think of it as shorthand for doing pl.col a times 2, pl.col b times 2, and pl.col c times 2. So the original multi-output expression gets expanded into three expressions, and each one is just a function from a data frame to a series. And that is how the original expression is able to produce multiple outputs, because we just think of it as being three expressions hidden all together. So in summary, what have we seen so far? We've seen that an expression is a function from a data frame to a series. We've seen how this expression can use multiple columns from the input data frame, but it only returns a single series as output. And finally, we saw how pl.col abc is shorthand for three expressions. So we should not think of this as just being a single expression, but three expressions in a trench coat. And we can then rest perfectly chill, knowing that everything is perfectly consistent and nice. But wait, what about group by aggregations? All right, let's touch on group by aggregations, because this is when things get a little bit trickier. Suppose we group a data frame by a column. Let's take a quick look at what's happening before talking about how expressions fit into this context. Say we've got some data frame of animals and their weights. We group by the names of the animals, and then we just aggregate using the expression pl.col weight. So let's see what this is doing. We're first dividing the original data frame into three sub-data frames corresponding to the different unique values of the column that we're grouping by. And what agg does is it then applies the expression to each sub-data frame and transposes the result horizontally. So we get this list float64 column in the output. Okay, so far so good. Let's take a little step back though, before trying to do an aggregation. What happens if we've got a column and we select an expression? So if we go from selecting pl.col weight to pl.col weight.sum, then we go from having a length 1 series to we go from having a length 3 series to a length 1 series. But crucially, notice how the data type is preserved. What about in a group by context though? Now, all of a sudden, we've gone from having a list float64 column to a float64 column. So the data type changed. What? Now, I think this is a good example of where practicality beats purity, because polars could have taken the decision to still return a list of float64 output, as shown here. So the result of the aggregation could have just been a list column where each list has got length 1. But as a user, is this really what you want? Would this really be useful to you? I think most of us, when we're using group by aggregations, we're expecting a single value to be returned per group, rather than a length 1 list. So what polars does instead is gives us exactly that. Group by aggregations aggregate to a single value. Now, maybe this does not align with some notion of perfect consistency, but I think it is what would be most useful to users, and so I commend polars on this decision. Let's have a little comparison with pandas syntax now for aggregations. I'm not going to do a speed comparison or anything like that, just comparing syntax. Because I think this is where expressions really allow polars to shine. If we want to do a non-trivial aggregation, then as long as we can express that with an expression, we can just put that in a group by context and voila, polars can evaluate it. But with the pandas syntax, we don't have a way to express this. We need to either use apply and a Python lambda, but using apply is typically going to be slow. We can either pre-compute b's mean per group, but that involves doing 2 group bys. There is actually a third way, but it's not obvious at all and relies on some implementation details. So not going to share it, but I do have a blog post about comparing pandas and polars group by aggregations, and you can find it there if you're interested. So speaking about pandas, could we use pandas to re-implement the concept of expressions? Let's take a step back. Suppose you've got a pandas data frame and you want to insert a column C, which is formed by taking column A and then adding 1 to it. So if you wanted to do this in pandas, there's a couple of ways you could do this. You could either do df square bracket C equals df square bracket A plus 1, or you could use assign and then put a lambda function inside. Now, personally, I'm not a huge fan of either. So the first method will modify the data frame, which isn't necessarily what we want to do. Like we might want to just return a new data frame with an extra column. And the second method involves using a lambda. And I don't know, these nameless, anonymous lambda functions, I think they're just a sign that there's something missing in the API. So what if we could express it like this in pandas? df equals df.assign C equals col A plus 1. And it turns out that it's actually very simple to implement a function which does this. You just need to keep in mind the mental model for expressions which we've been looking at so far. And you can make an expression class like this, give it a dunder call method, and then make a function called call, which will return that expression class instantiated with a function which takes the data frame and returns the column given by the column name, which is passed to this call function. So that's all we're doing. We're instantiating this extra class with a function. We then need to override some dunder methods. And there you go. You've got something that looks a bit like expressions from polars, but implemented entirely using pandas. And if you try to then use that in pandas, you'll find that it works without needing to make any modifications in pandas itself. Now, just because it's possible to do it, does that mean you should? I don't know, and I'm curious to hear your opinion in the chat. Should pandas adopt this kind of syntax, or should it just stick to assign with lambda functions? Curious to hear people's thoughts. Speaking of expressions, if you like the idea of writing code which can dispatch to different backends using expressions, then you might be interested in a project called Narwhals. Narwhals uses expressions. It's essentially a subset of the polars API, and it allows you to write code which can support multiple major data frame backends. And like this, you can write code which is totally data frame agnostic, allowing the user to bring their own data frame. If the user brings Dask, then they can run everything using Dask without requiring additional dependencies, and similarly for the other backends. It's a project which had its first release in February of this year, 2024, but it's already been used by some major libraries in the data ecosystem, including Altair, scikit-lego, Marimo, Vega Fusion, Shiny, Plotly. Well, Plotly, they've merged a pull request but haven't made a release yet. Maybe by the time somebody's watching this on YouTube, they will have made a release. I don't know. Hopefully they do that and don't change their mind. But yeah, hopefully more are on their way. So maybe expressions do give us a way to bring the ecosystem together. Contributions are super welcome. And if you'd like a bit of help with this, then please join PyLadiesCon 2024. There will be a mentored sprint there, and some of us can help you make your first open source contributions. Would be awesome to see you there. So in conclusion, what have we learned today? We've learned how expressions are the primary and most idiomatic way of interacting with polars, and we can think of them as just being functions from data frames to series. And being functions, they don't produce values until they're given inputs, so they allow for some nice optimizations. We then saw how polars deviate slightly from perfect consistency for the sake of user-friendliness, and that there's nothing magical about expressions, and if we want to, we can re-implement them in pandas. I hope that I've whet your appetite for polars and have convinced you that expressions are a good way of working with the library, as opposed to doing everything using square brackets and series. If I didn't, then, as you might say in the Netherlands, helaas, pindakaas. Thank you, everybody. I'm happy to take some questions if there are any. Otherwise, happy to let everyone get on with their days. Thank you. Right, in the Q&A, got some questions. So, do polars expressions support annotations, as in like Python typing annotations? You can annotate your expressions if you want to. Like there is a class for them called expra, and you can also define a class into expra, like as a union of string and series and expression, which is the users can interpret as anything which can be converted into an expression. In general, the library is very strongly statically typed. So yeah, if you enjoy static typing, then I think polars is a good library. We've got the chat. Okay, got a question in the chat from Irv Lustig, core developer of pandas, and I think the primary person behind the pandas type annotations. So if you like type annotations and prefer to use pandas, then check out pandas type stubs. Having said that, Irv did ask a question, which is, if I'm starting a new project, do I now use polars and not use pandas? Not necessarily. I might use DuckDB. It depends. Yeah, if I'm starting a new project, then yeah, typically I'd gravitate towards one of these tools. I think for geospatial analysis, that's an area where pandas is still leading the way in terms of integrations. I think largely thanks to GeoPandas, which one of the pandas devs, Joris, is working heavily on. But yeah, I don't know. My general thinking about it is like, if it's not broken, don't fix it. So if anyone's got an existing pandas project and it's not broken, then I don't think there's much of a reason to switch. But if you're starting a new project, I think that's a good chance to give a new tool a spin. Can I clarify what size datasets are for polars? So currently it'll work for when you've got data that can fit in memory. There is so with lazy optimization, it can sometimes manage to process data that's larger in memory if the kinds of operations that you're doing reduce your dataset size such that the moment it needs to be materialized, it does fit in memory. So if you need to process like 100 terabytes of data on your laptop, then maybe, what's it called? Maybe DuckDB would be a better choice. However, polars is working on a new streaming engine, which should be available later this year, early next year, I don't know. But at some point, there is going to be a super amazing and powerful streaming API in polars. So at that point, you should be able to process much larger than memory datasets on your laptop. So pretty exciting stuff. Okay, got a question from Stefan van der Walt, a very important figure in the PyData ecosystem. So excited to have you here. Is Narwhals a way to provide an array API equivalent for data frames? Yes, that's exactly the idea. Although, in fact, locally, the folder in which I've got it is still called something like Polars API compat. But then I figured, nah, this is too dry of a name. If we want people to use it, we need to have something a bit sillier, a bit catchier. And I think I must have been in a particularly silly mood that day, because I then named it after the Mr. Weeble song Narwhals. But that's the idea, yeah, something like the array API compat. The array API is also trying to standardize things in the sense that array libraries are also converging towards the array API spec, whereas Narwhals isn't trying to pressure pandas or polars or anyone else to change their APIs. It's just a third-party library which can hopefully bring things together and allow for our tools to not be tied to one particular library and let users pass in whatever they prefer. Good one. So, how is it able to achieve multi-threading since Python has an interpreter lock? Most of the operations in Polars are written in Rust, which provides you with some really nice mechanisms for multi-threading. So, yeah, that's how, by not doing it in Python. What are some options for plotting data in Polars? So, Altair and Vega Fusion are now dataframe-agnostic, thanks to Narwhals. And Plotly should hopefully be making a release this year, also using Narwhals. So all of these should be able to accept Polars input natively. So they should be able to operate on it directly without requiring extra dependencies and without converting to pandas or to PyArrow. So I think, yeah, Altair, Vega Fusion, Plotly, I think these are currently the strongest options. And Bokeh have also signaled that they'd be open to Narwhals support. So I don't know, hopefully with Narwhals we can take over the visualization landscape in Python. Okay. I think that's all of the active.
There's a few more
questions. Oh, there's a few more. All right. Yeah, I think I answered Stefan's one. And then, could we use Polars as input data into scikit-learn? Yes, you can. Scikit-learn should accept Polars in most places. If it doesn't, then this is considered a bug. So please open an issue and it can be fixed. When you make a copy of a data frame, is it still a shallow copy? Yes. So yeah, doing .clone on a data frame isn't expensive until you modify a series. And even then, it'll only copy the series which you've written to, not all of the other ones which you've left alone. Pandas is also moving towards this kind of model, copy on write, which will be the default in Pandas version 3, which should be out at some point. Any disadvantages to using Polars? So if you're very heavily using the index in Pandas, then that is something you might miss when you're in Polars. I mean, personally, I was one of those Pandas users who would do reset index every other minute. So I was very happy to be able to use a tool that didn't have the index. But if you really like the index, and especially the multi-index, then yeah, you might miss that in Polars. Right, should I learn Polars instead of pandas? Ooh, that's a good one. If you're a beginner and you don't know either, should you learn Polars instead of pandas? I mean, I do think that the learning curve is a bit lower because the API is more consistent. However, if you want to work with other people and get a job, then most jobs are probably still going to ask you to know pandas. So I guess it's somewhat situation dependent. All right. Well, very active Q&A. We've done well. Last chance, any more questions? Yeah, well done, people. That was a pretty active chat. All right. Well, yeah, hope to see some of you on GitHub and or at the Narwhals sprint at PyLadiesCon later this year. Thanks, everybody, and thanks, Reshama, for inviting me.
Thank you, Marco. Yep, thank you so much. And we'll be in touch, and you're going to send us slides, and we'll link the slides to the video, and the video will be up within a day. So thank you, everybody.
Cool. Thanks, everybody. Thanks for the emoji reactions.